Okay, this is 1.K9.1 properties for solving equations. So we're going to basically go through all of these different properties that are involved in the different steps when you solve an equation. So starting with the additive inverse property, the additive inverse is subtraction. Okay, what this means, this is what you would need to add to a number to create 0. So typically you do this when you are canceling on both sides of the equal sign. Okay, so an example of this would be if I start with -5, I'm going to add a +5, and that will give me 0. Okay, next is the multiplicative inverse. So similar situation here. Basically, this is going to be what we multiply to a number to get 1. And this is going to be division. So whenever you are getting x by itself, a lot of times this happens. You undo multiplication by doing division. Okay, so an example of this could be 5 divided by 5 gives me 1. You may also see this written a similar way as 5 times 1/5. That is also equal to 1, and those are equivalent. Okay, next we have the equality property. This is whenever we say that if you do something to one side of the equation, you must do it to the other side to maintain that equality and balanced equation. So what you do to one side of the equal sign, so that's very important. Must be done to the other. So an example of this, if we had the equation 5x minus 8 equals 7. In order to start solving for x, I would do my additive inverse here. Instead of -8, I would add 8 to create 0. And since I did that on the left side, I must now also do that to the other side of the equal sign there to keep the equation balanced and to keep that equality. Okay. So that is an example of the equality property. Okay, now we have the commutative property. Commute means to move, right? If you are commuting to work, you are driving to work. You are moving in a vehicle. So, let's say to move. And so what this means is that you can swap numbers around but still get the same answer. Okay, and this only works for addition and multiplication. So an example, I've got a few here. Oops. Okay, so if I have one number, my addition example, A plus B, this is the same thing. I can swap those around, right? So to swap or move, that is the same thing as B plus A, okay? And that does not change the value at all. Those are equal. An example with multiplication, say I have 2 times 5, which is 10. I can swap the order of those to 5 times 2, and that would be the same answer. Okay, so that is the commutative property. Next is the associative property. This is all about grouping. Okay, so remember, who you associate with is your group of people. Okay, so always think of grouping when you think of this. What this tells us is that it doesn't matter how we group the numbers, telling us what to calculate first, okay? But this only works for addition and multiplication. So order in groups can change. So let's look at some examples to see what this looks like. If I have 6 plus 3, that's one group because they're in parentheses, plus 4, this can be rearranged. This equals 6 plus, now I can change where those parentheses are and do 3 plus 4 in a group, okay? A similar situation happens for multiplication. If I have 2 times 4 grouped together and then multiply that by 3, that is the same answer as 2 times 4 times 3 grouped together, okay? Only works for addition and multiplication. This is helpful if you need to rearrange an equation to make it more comfortable for you to solve. You can use this idea. Okay, next we have the distributive property, which we've talked about before. But basically, this is just two ways of saying the same thing. Okay, so in this example, we have 3 times 2 plus 4. This means that 3 lots of 2 plus 4 is the same as 3 lots, you can look at the picture on the left here, of 2 plus 3 lots of 4. Okay, that picture on the left there shows it 3 rows that have 2 and 4. And then on the other side, it shows a rectangle of 3 times 2, and then another rectangle of 3 times 4, and just shows that those are the same thing but split up. Okay, so that's basically what you're doing when you're doing the distributive property. So we can write out what that says. That says it equals 3 times 2 plus 3 times 4. Okay, so when you're distributing, we'll do an example here. Another one. You are taking that number in the front and distributing it to both the 2 and the 4. So if we look at -2 times 6 plus x, this is a similar example but with a variable. This equals -2 times the 6, right? So I distributed the 2 there. And then plus 2 times the x there. So -2 times x. That is the same way to write that. Okay, next we have combining like terms. So what this means is that we can add like terms together to make one term. Okay, this is very helpful when you are simplifying both sides of the equal sign. If you have any terms that look alike, you can go ahead and combine them as long as they are on the same side of the equal sign. So if we look at this expression here, I'm going to zoom in. We've got -4 plus 4x minus 2x squared minus 5 plus 10x. Okay, so I see a lot of different stuff going on in this expression, but I see some things that are alike. So I notice that -4 doesn't have a variable with it, and neither does this -5 here. So I can add those together because they are alike. -4 minus 5 is -9. I see this 4x here. And then I also see at the very end, I see a 10x. Those are like terms as well. So 4x plus 10x would give me 14. So I can go ahead and add 14x. And then lastly, I see this term that has an x squared on it, this minus 2x squared. I don't see anything else in here that has an x squared on it. So that is its only like term. We're not going to combine it with anything, but we will still add it on at the end. Okay, now we have the additive identity property. So identity means who you are, right? So what numbers originally are. So these are the operations that we can do to a number to leave it with the same identity. Okay, so for the additive identity, this is 0. So this is an operation that leaves, or let's say does not change the identity. And so for this one, this is 0 for addition. So let's look at y. If you have any number and you add 0 to it, so say 7 plus 0, or 0 plus 7, this will always give you 7. It does not change the value of that number. So that equals 7. Okay, so then there's also a multiplicative identity. There's an operation that we can use with multiplication that doesn't change its value, but it's a different operation. Okay, so we can copy this definition again. An operation that doesn't change the identity or value of a number. And so with multiplication, this would be multiplying by 1. Okay? So let's look at y. Here's an example. Negative 12 times 1, or 1 times negative 12. These both give us negative 12, which is the original number that we were multiplying by. So this did not change the value of that number or its identity. Okay, these are all of the properties that we use when solving equations. So we will start to practice identifying these properties as we are solving.